All right, congratulations. Welcome to the final survey of calculus video. We're going to do this one example and then wrap it up. So we've got a firm's marginal profit as a function of its total cost as given by the equation below. So here's our marginal profit as a function of cost. We want to go ahead and find the profit function. So this is actually an application of using differential equations. We're going to find the profit function, and then we're going to figure out the break-even point of the business, which is extremely important. If you are a business owner, you need to know your break-even point because that's how much profit you have to make. That's how much revenue you have to make to pay all of your costs. Excuse me, so let's do it. As usual, we separate our variables. So I separated my variables just like that, and now we're going to take the integral of both sides. So when we do, we'll get p over here, and let's see what happens with this fraction. All right, in fact, before I even do this, I'm going to keep the integral for a second because I want to rewrite this. This will be negative 210 of c plus 5 to the negative 3/2 over 1. So let's go ahead and see what this integral is going to do. So all I did is just move that upstairs. I did not take the integral yet. This will be negative 210 c plus 5 to the negative 1/2, and that's because minus 1 will get us to negative 3/2. So that means when I take the derivative of this, I need to cancel the negative 1/2. So down here we have a negative 1/2. Okay, so that's where we are right now, and because this is a constant and this is cost for c, I don't want to confuse myself, so that's just a number, whereas that's actually a variable in the equation. So that's why I'm going to call this C1, because I don't want to confuse this C with that C. That's the hardest step right there. If this makes sense, I'm happy. If it doesn't, please send me an email. Basically, when you take the derivative of this, the negative 1/2 comes over out here, which cancels the negative 1/2. Then you subtract 1 to get negative 3/2. So we don't have to worry about chain rule because we just have c plus 5 in here. As you can imagine, this gets much more difficult if the integral is more difficult. Dividing by 1/2 is the same thing as multiplying by 2. So this is the same as multiplying by negative 2. So my profit function is 420 times c plus 5 to the negative 1/2 plus my constant function. Or if we want, we can write it like this. Like that. So there is the first question answered. We have our profit function. 420 divided by the square root of c plus 5 plus a constant. They then say to find the profit function if a profit of $14 corresponds with a cost of 20. So up here it says if we have a profit of if we have a cost of 20, we get a profit of $14. So all I need to do is plug that down here and here. Notice I'm not plugging in for this. I'm solving for this variable. That's why I denoted it C1. I'm plugging in for P and C. So if my profit is $14, it's 14 is equal to 420 divided by the square root of C plus 5. Okay. And my cost, I should have put in a value of 20. Plus C1. So that's what we've got, and this is going to work out kind of nicely because down here we just have the square root of 25, which is just 5. So that's going to be 420 divided by 5, which is 84. Okay, so again, that's 20 plus 5 is 25. The square root of that became 5. So we'll get that my constant is equal to negative 70 when I do minus 84 and minus 84. So my updated function is p equals 420 divided by c plus 5 minus 70, because we've isolated our constant term by plugging in an actual value of the function. Remember, we also call this an initial condition, and we get our new function right here. Finally, they say, what is the break-even point? The break-even point is when you have zero profit. And zero profit sounds bad, but it can actually be wonderful. Zero profit means you're not losing money. And for a lot of businesses, they go through a process of losing money before they actually hit the break-even point. So now we're just going to solve this equation right here so that we can find our break-even point. So add the 70 over. And then we'll times by the square root. So I've got 70. All I did is multiply both sides by the square root of c plus 5 to cancel the square root. So I have 70 times the square root of c plus 5 equals 420. Divide by 70 on both sides. So we have the square root of c plus 5 is equal to 420 divided by 70, which is 6. Almost done. Square both sides. C plus 5 is equal to 36, and then just move the 5 over. So when our cost is 31, that means we have finally hit our break-even point, and that is indeed the answer. So if you have any questions on that, please email me. Hey, I want to congratulate you on making it this far. This completes the syllabus for the Survey of Calculus. My hope is that you're actually interested in this enough that you would someday want to take calculus, because calculus is actually my favorite math class to teach out of all of them. And my hope is that you understand derivatives and integrals, basic differential equations and some of their applications, and the cool part about how derivatives are the reverse of integrals, which is the fundamental theorem of calculus, which is just wonderful. I hope you enjoyed it. Thanks again for making it this far. If there's anything I can do to help you succeed, please let me know, and I'll see you another time. Take care.